নমস্কার, দেখছেন নিউজ 18 বাংলা। আপনাদের সঙ্গে রয়েছে আমি পায়েল। আইসিএসসি ক্লাসরুম শনিবার সকাল 11টা মানে সময় হয়ে গিয়েছে আইসিএসসি ক্লাসরুম। আর তাইও আজ আমরা চলে এসেছি কেন আইসিএসসি ক্লাসরুম, যাতে তোমরা বাড়িতে বসে তোমাদের সিলেবাস শেষ করতে পারো খুব তাড়াতাড়ি। আর তার জন্যই আমাদের এই ক্লাসরুম। আর আজ আমরা পড়ব ম্যাথস, এবং আমাদের পড়ানোর জন্য অবশ্যই আমাদের সঙ্গে দুজন ম্যাম রয়েছে। তাদের সঙ্গে প্রথমে একটু আলাপ সেরে নিই। আমার সঙ্গে রয়েছেন কৃতিকা হাজরা, দ্য ফিউচার ফাউন্ডেশন স্কুলের প্রাইমারি ম্যাথস আমাদেরকে পড়াবেন। ম্যাম, ওয়েলকাম টু আওয়ার শো। এবং অপরদিকে আমার সঙ্গে রয়েছেন শাশ্বতী মুখার্জি, সেন্ট থমাস গার্লস স্কুলের আপার প্রাইমারি ম্যাথস আমাদেরকে পড়াবেন। ম্যাম, আপনাকেও স্বাগত জানাই নিউজ 18 বাংলায়। আমাদের ক্লাসরুম আমরা শুরু করব, তবে তার আগে বার্তা, ভিডিও বার্তা। কার ভিডিও বার্তা? CISCEর চিফ এক্সিকিউটিভ অ্যান্ড সেক্রেটারি জেডি আরাথনের ভিডিও বার্তা। একবার দেখে নাও।
As we are all aware, schools are shut and no classes are being held due to the lockdown. The Council has taken the initiative to conduct live lessons on News 18 Bangla channel for the subjects English and Mathematics for junior and middle school children from classes 3 to 8. These live lessons are being conducted by the Council's subject experts. The objectives for conducting these live lessons are to present selective elements of these two core subjects, English and Mathematics, to develop an interest in these subjects through simple games and activities, so that children are able to relate and apply learned concepts to real-life situations. I request all children of our council schools to participate actively in this program, stay in touch with your studies, and continue to learn through these live lessons.
তাহলে এবার আমাদের ক্লাস শুরু করা যাক। প্রথমেই প্রাইমারি ম্যাথস আমরা শিখব। আমাদের সঙ্গে তো রয়েছে ম্যাম কৃতিকা হাজরা। ম্যাম, এবার ওভার টু ইউ একেবারে।
Good morning, children. Welcome to another maths class. Let us learn something together. In previous classes, all of us have been learning about large numbers. You know how to express them using Indian and international systems. But have you ever experienced large numbers? Have you ever felt them? Have you ever been in a train full of people? Let us turn to an activity through which we will try to feel the large numbers. You need a cup full of rice grains and a few bowls. Count 10 rice grains. Put them into one bowl. Now repeat this activity 10 more times. But hold on, you cannot count this time. Remember the feeling of holding those 10 grains? Use that to take it 10 more times. So 10 more times 10 grains is 100 grains. Now use this feeling to take 10 more times. So 10 more times 100 grains is 1000 grains. Now you need your mother's help. The measuring cup she uses to take rice grains before she starts cooking rice, you pour these 1000 grains into that. How full is the cup? Is it totally filled, or half filled, or quarter? By this, you can understand how many rice grains go into cooking daily. Also, you can understand how many rice grains you waste if you don't eat them properly. Hold on. Did I use any new terms? One whole. A half. Half of a chocolate. Oh, it's 10:30, my short break time. 6:45, study time. Let us learn some more about these numbers. These are all Jodo blocks. Jodo in the sense joining. I can break them and I can join them. So this stick has 8 Jodo blocks. I want to break this stick into equal parts, equal 2 parts. So from these 2 parts, I am taking 1 part. How do I write it? I write 1 out of 2 equal parts. Again, let us take this Jodo stick, and this time I want to break it into 4 equal parts. So 1, 2, 3 and 4. From here, again I want to take 1 part. So 1 part out of 4 equal parts. How do I write it? I write 1 out of 4. This time a Jodo stick, but with 9 blocks. Alright. Now I want to break it into 3 equal parts. 1, 2 and 3. You can see I have 3 equal parts. And from these 3 parts, I will take 2 parts. So I have 2 out of 3. So this is how I express fractions. Let's summarize. The selected parts go at the top and the total number of parts come at the bottom. The top part is called numerator and the bottom part is called denominator. Using this idea, let us try to solve these. How much is this shaded? How much is this? And this. Let us try to do these by ourselves. So the first one is 1 red part out of 4 parts. So how do I write it? I write 1 out of 4 or 1 by 4. It is also called 1/4. What about the second one? I have 2 parts shaded out of 6 equal parts. So 2/6 or 2 out of 6. What about the last one? Oh, I see all the 3 parts are shaded. So 3 out of 3 or 3/3. Can I also say that the whole circle is shaded? Okay, now I am going to give you some fractions and you are going to tell me if there is any common things in those fractions. What common properties do these fractions have? 1 by 2, 1 by 3, 1 by 10, 100th, 1 by 200 and so on. Tell me, what common property do you notice? Oh, I see all of them have numerator as 1 and they have a special name. They are called unit fractions because their numerators are having 1 or unit. Alright? This is another set of fractions. This time tell me, what is the common property? Now, this time not the numerators. Is it the denominator then? Oh yes, I see all the denominators are 10. That means all the fractions are equally divided into 10 parts. Now take an apple. Suppose it is divided into 10 equal parts and you take 1 part of it and you represent this as 1 out of 10. Now you take that yummy brownie you saw and you divide that into 10 equal parts again and you take 7 out of it. Or you take a chapati and divide that again into 10 equal parts and you take 5 part of it and you represent that as 5 out of 10. Alright, so these kind of fractions have a special name too. They are called like fractions. Alright, now it's your time. You tell me that what kind of fractions will be unlike. Let us see. Do you agree? Of course, the unlike fractions will not have any same denominator or any common denominator, right? Let's have some pizzas. All right. from the right pizza I had 4 equal parts, and from the left pizza I had 1 part. All right, so from the left one I had 1 part, and from the right one I had 4 parts. The question is, from which one I had more? Let's hold the question a bit and let's turn our attention again to Jodo stick. All right, again I have a 8 block Jodo, and again I want to break it into 2 equal parts. I see they are equal, and I am keeping 1 equal part with myself. So how do I write it? I write 1/2. Another Jodo stick, again with 8 blocks but a different color. This time I will break it into 4 equal parts. 1, 2, 3 and 4. And from these 4 parts I will take 2 parts. I have taken 2 parts, and I am going to keep these parts with me separately. Another Jodo stick, this time white, again 8 blocks, but I will break it up into 8 equal parts. So 1, 2, 3, 4, 5, 6, 7 and 8. I have 8 equal parts with me, and from here I am going to take 4 parts and keep this with the rest of the bars. All right, let's notice something. From the first one I had half, from the second I had taken 2/4, and from the third I had taken 4/8. But what do I notice? All the blocks are of same length. How is that even possible? Because all the denominators were different, right? So is it this? Is it half equal to 2/4 equal to 4/8? How is that even happening? Let us try to figure that out and tell me if you agree with me. So half, if I multiply 2 with the numerator and 2 with the denominator, I get 2 out of 4. With 2 out of 4, if I multiply 2 with the numerator and 2 with the denominator, I get 4 out of 8. And again half, if I multiply 4 with the numerator, 4 with the denominator, I get 4 out of 8. So do you agree now that all these parts are equal? I can multiply a same number with the denominator and with the numerator to get similar kinds of fraction, and they have a special name. They are called equivalent fractions. Now you can ask me, why only multiplication? Why can't I divide? Let's try to figure out that. Let us take 4 out of 10. So 4 parts out of 10 parts. And I want to divide by 4. So as we just saw that whatever I multiply with the denominator has to be multiplied with the numerator, the same should be applied for division as well. So I want to divide 4 by 4 and 10 by 4. Oh, what do I see? I can't divide 10 by 4. Let us try to divide by 2. Oh, it happened, and I got 2 by 5. Okay, so can you tell me what is there in the second one which is not there in the first? Yes, 2 is a common factor of 4 and 10, but 4 is not a common factor of 4 and 10. All right, so I need a common factor to divide. Do you remember what is a common factor? So a common factor is a number which can divide both the numbers or more than that, and I have no remainder left. Take an example, take 10 and 5, and the common factor of 10 and 5 is 5. I can divide them leaving no remainder.
আমাদের একটা শর্ট ব্রেক নিতেই হচ্ছে, আমরা আবারও আসছি আলোচনায়, তবে একটা ছোট্ট বিরতির পর সঙ্গে থাকো। ব্রেকের পর ফিরলাম আইসিএসসি ক্লাসরুমে, আবারও ম্যামের কাছে চলে যাব। ম্যাম,
So we were discussing about a common factor, right? Now let us do some more of these work together. Get your paper and pen. So 6 out of 9. So what is the common factor? I have 3. So I can divide by 3 and I get to 2 out of 3. Let's do another. 10 out of 20. So I can divide by 2 because 2 is a common factor and I reach at 5 out of 10. Let's wait and think, what is the difference between 2 out of 3 and 5 out of 10? So 2 and 3 do not have any common factor except 1. You saw in the last slide, 2 out of 5 also did not have a common factor except 1. So I will continue the division till I reach a fraction where there is no common factor except 1. So that means 5 out of 10, I have to go on with this because 5 is a common factor. So I can divide by 5 and I get to 1 out of 2 or half. I can stop here because they do not have any common factor except 1. Let us do this together. 12 out of 16, I continue till I reach a fraction which is 3 out of 4, which do not have any common factor except 1. And these kind of fractions are called simplest fractions or simplest form of fractions. Now observe one thing. Is 3 out of 4 same as 12 out of 16 if I multiply both the numerators and the denominators with 4? So it is same as equivalent fraction. So equivalent fractions and simplest form are both the things same. All right. So let us get back to our question on pizza. So I had these 2 pizzas and from the first one I had eaten 1 part and from the second one I had eaten 4 parts. That means I had eaten half from the first one and 4 out of 8 from the second one. Oh, I made a fool. I actually ate the same amount from both the pizzas because 4 out of 8 in simplest form is same as 1 out of 2. So actually I had the whole pizza by myself. All right, this question is for you. If I gave you 1/2 or 2/4 of this chocolate bar, which one would you prefer? Remember, you cannot have the whole. All right, let us play a game now. Now you need some cards here. You can make these cards by just clicking the pictures and making it by yourself at home. So this is my first set of 4 cards. This is another set of 4 cards. These are another set and another 4 cards. So altogether I am having 16 cards. So what you have to do is you have to make 4 groups of 4 cards. So 4 groups of 4 cards will be 16 cards. But in each group there has to be something in common. That means when you make a group, there has to be some common factor present in each groups. All right. So I am going to help you with one group. All right. Let us start with half. All right. So I am taking half. That means in my group I will have all the cards which are something about half, which have some common factor regarding half. But there are 16 cards. I have to try and figure out. Okay, let's take this card. Is it half? No. I see 3 parts out of 4 parts are shaded. That means it is 3/4 and then it can't belong to my group. I keep it aside. Let's take this one. Let's count how many total dots. I have 12 dots and among them 9 are shaded or 9 are black dots. So what is the fraction of the shaded portion? I have 9 out of 12. Now what is 9 out of 12 in simplest form? What is the common factor? The common factor is 3. So I can divide 9 by 3 and 12 also by 3, and I reach at 3 out of 4. Again, this is not in my group. Alright, let's take this. Oh, it's a neat half, and this will belong to my group. Great. Let us take this one. Again, dots. I have again 12 dots, and how many dots are shaded? I have 6 shaded dots. So 6 out of 12 is nothing but half, because 6 is a common factor. So I have this card with me. So I need one more card. Let's take these boxes. How many total boxes? Again, I have 12 total boxes. How many are shaded? I have 4 shaded. So 4 out of 12 is nothing but, what's the common factor? Common factor is 4. So 4 out of 12 is nothing but 1 out of 3. Again, not in my group. Alright, let's try this one. I have 6 shaded out of total 12 boxes, and which is nothing but 6 out of 12, which is half. So I have my group made, which has all the halves with me. Alright, so what you can do, you make all these 16 cards and find the rest of the groups. Alright, let us give you a brain teaser. Now this is a square. Is this only a square? No, I can see many squares, and I can see many triangles as well. What you have to do is, using the triangles, you have to first divide this full square into 2 equal parts. Alright, you can use 2 different colors to shade the 2 parts. So quickly you can take a picture of this square and make it, draw and make it, and actually color it. Alright, so first you have to divide this into 2 equal parts by shading it, but that's not the end of it. You have to divide this into 3 equal parts as well. So you need another square made and use 3 different colors to do that, and also 6 equal parts. So another square made, use 6 different colors to do that. Alright, I thought of helping you a bit. I'm going to show you the 3 equal parts. Tell me if you agree with me. Do you agree or not? You might say that how do I understand they're all 3 equal? Because I see all the 3 different colors are scattered. So this is again you to figure out if my coloring is perfect or not, and if there are many more ways of coloring or not. So that is also you to figure out. Fine. So you can do this one by yourself and have come to different questions. This is the last one, which you can use these sites to do a lot more fun at home. Alright? So, have a nice time. Goodbye.
একেবারে ম্যাম এত সুন্দর করে বুঝিয়েছে, আমার তো ধারণা যারা এতক্ষণ আমাদের সঙ্গে আছে তাদের কাছে খুব ইজি হয়ে গেছে আর খুব হেল্পফুল পুরো বিষয়টা। তবে এরপর বড়দের একটু সুযোগ দিতে হবে, বড়দের পালা, অর্থাৎ আপার প্রাইমারি ম্যাথস আমরা পড়বো। আমাদের সঙ্গে তো ম্যাম রয়েছেনই, তবে একটা শর্ট ব্রেকের পর সঙ্গে থাকো।
मैडम ये तो जादू की छड़ी है।
इसलिए अपने फैब्रिकेटर को बोलिए कि ग्रिल बनाए तो
सिर्फ SRMB रियल स्टील से।
ব্রেকের পর ফিরলাম আইসিএসসি ক্লাসরুমে। বড়রা তৈরি তো? খাতা পেন নিয়ে একেবারে টিভির সামনে বসে পড়েছো? তাহলে আর দেরি না করে শুরু করা যাক আপার প্রাইমারি ক্লাস। ম্যাম।
Thank you. Good morning everyone. So we will be doing mathematics at the upper primary level. The topic for today is visualization and identification of 3D figures transformation from 3D to 2D figures, and then looking for symmetry in the 2D figures. I've divided the topic into two sections. The first topic is visualization and recognition of solids. Before we move on to anything, we must have a clear concept of dimension. Let us take a point. If you look at a point has no length and no breadth. Since it has no length and no breadth, we say it is of 0 dimension. If we take a line segment, it has length and almost negligible breadth, so it is 1 dimensional. If we look at a square, the next figure, which has length and breadth, we say it is a 2-dimensional figure. If we move on to the next figure which we have, it is a cube. It has length, breadth and height. Since it has 3 dimension, it is a 3-dimensional figure. So if we move on to the definition of a 3-dimensional figure, a 3-dimensional figure is a figure which has length, breadth and height. Any enclosed 3D shape will be called a solid. Now very quickly you can move around and look for the common 3D shapes which you have in your drawing room and see whether it matches with one of the objects which I will be showing. It can be a book, it can be a dice, it can be something, a pencil box, something from the kitchen, a kitchenware, a hat, it can be the remote of your television set, it can be the mobile phone which you are using. Any object which you have collected is actually a 3D shape. 3D shape takes up space. Only the 3D shape will occupy its own space. No other human being can stand actually where you are standing. Suppose I am standing here at this position. Now, if you have to give place for somebody else to come and stand here, I have to move out of this space and give that place to somebody else. Now, I will move on to the concept of faces, edges and vertices, taking something as an example. Look at this. This box is in a shape of a cuboid. Okay? See, it has length, it has breadth and it has height. So, this shape is called a cuboid. I will explain face. I have named this surface as 1. What is this basically? It is a 2-dimensional shape which shows one surface of a 3D shape. So, basically this is a 2D shape which is representing one surface of this entire figure. See, I have marked these as 1, 2, 3 and if you start counting, you will see that there are 6 faces. Now, we move on to the concept of edge. What is an edge? The faces where it meets is the edge. So, if I look at these two faces, see face 1 and face 3 which I have here. So, this is the line which joins these two faces. So, this line will be called an edge. If I move on to the concept of vertices, look at this point. What is this point? Where the edges meet, where the lines meet. So, these points where the lines meet are called the vertices of the figure. Now, look at this slide. Now, can you understand clearly, students, that this surface is the face, this line which is marked in red is the edge and these are the vertices of the figure. Standard 3D figures which we have in mathematics, it can be a cube, it can be a cuboid, a cylinder, a polytetrahedron, it can be a cone or it can be a prism. See, some of the 3-dimensional figures, I have made it for you as an example. So, this is a cube. Can you see this, students? This is a cylinder. This is a sphere. All these are 3-dimensional figures. I've made a few for you to see so that you can try some for your home activity. What is a polyhedron? A polyhedron is a solid which is enclosed by polygons. It only has flat surfaces. Now see, I am taking this sphere which I had just shown you as a three-dimensional figure. Will you call this a polyhedron? This is not a polyhedron because this is a three-dimensional shape which has no flat surface. If you look at the sphere clearly, it does not have any flat surface. So this is just a three-dimensional shape and not a polyhedron. Look at these standard polyhedrons which we have. The first one is a cube, then we have a pyramid, and then we have a cuboid. So see, I have made a cube for you, and just now I said that this is a cuboid. This is a cube which I have, and this is a cuboid. Now, what is the difference between a cube and a cuboid? A cube, all the sides are equal in the cube, and in a cuboid, the dimensions are different. The length, breadth and height are different. So, the basic difference between a cube and a cuboid is, in a cube, all the sides are same, and in a cuboid, you have different dimensions. Now, if we move on to counting of faces, edges and vertices in common polyhedrons which we have. See, I have made out this table for you. If you have papers and pencils, you can take down this table. It has the normal polyhedrons, cuboid, cube, triangular prism, pentagonal prism or hexagonal prism, and I'll start counting the number of faces, the number of vertices, edges, and see. Just have a look at this cuboid which I have in my hand once more. Yes, if I start counting the number of faces, 1, 2, 3, 4, 5 and 6. So, it has 6 faces. If I start counting the number of vertex are these points. Okay, 1, 2, 3, 4, 5, 6, 7 and 8. If we count the number of edges, I told you what an edge is, the line which joins the faces. If you start counting the edges like this, you will find that they are 12 in number. The next column, which is F plus V, you add the column of F and you add the column of V, you get it as 14. Now, you add 2 to the edge. So, you will again get 12 plus 2 is 14. If I move on to a cube, just now I said a cube is almost a similar figure to cuboid, but only the difference is that in this cube, all the 6 sides are equal. So, if you count the number of vertices, edges and faces, you will find they will exactly be the same as that of cuboid. So, F plus V will be equal to E plus 2. If I take a prism, this is a triangular prism. If I start counting the number of faces, 1, 2, 3, 4 and 5. So, I see there are 5 faces. In the same way, if I start counting the number of vertices, 1, 2, 3, you will see that there are 6 vertices. If I start counting the edges, these are the edges. If I start counting the edges, you will find that they are 9 in number. So, again if you add up F plus V, you will get it as E plus 2. Both will come to 11. You can finish the rest of the table for yourself, the pentagonal prism and hexagonal prism. And what did you observe from this table? You observed that F plus V is equal to E plus 2. Is it the same for all figures? Yes, it is the same for all polyhedrons, that F plus V will be equal to E plus 2. So, the common formula which we get from here, that F plus V is equal to E plus 2, students, is Euler's formula. Now, if we take up a problem that can we have a polyhedron where there are 10 faces, 20 edges and 13 vertices. We use F for the abbreviation of face, we use E for edges and we use V for vertices. So, if we add up F plus V, we get it as 23, and if we add up E plus 2, that means 20 plus 2, it is 22. So, 23 is not equal to 22, so we cannot have a polyhedron of these dimensions. If we move on to the next problem which we have, faces is unknown. We have taken the number of vertices as 6 and number of edges as 12. You have done equation, students. The students who have just come in from class 5 to class 6 may not know equations, you learn it very soon, but classes 7 and 8 students, you know what is equation. In order to solve it, you just apply the Euler's formula which we have just learned, that F plus V is equal to E plus 2. So, we substitute the value of F plus V. Okay, so F is the unknown quantity here. So, you know that in order to find out an unknown quantity, we use the term either F, X, Y, anything. These terms are stands for the unknown quantities. You get the value of F. If you take the plus 6 from the left hand side of the equation to the right hand side of the equation, you get it as minus 6. Now, if we move on to the nets for the 3D figure, what is a net? Net is basically any figure which you draw in the two-dimensional shape and fold it up in order.
প্রোগ্রামের দিকে আসবো, এই প্রবলেম আমরা সলভ করব, পাশাপাশি আরো অনেক ম্যাথমেটিক্সের প্রবলেম সলভ করব খুব ইজিলি। ম্যামরা তো রয়েছেন, তবে শর্ট ব্রেকের পর সঙ্গে থাকো।
मैडम ये तो जादू की छड़ी है।
इसलिए अपने फैब्रिकेटर को बोलिए कि ग्रिल बनाए तो
सिर्फ SRMB रियल स्टील से।
ফিল্ম আইসিএসসি ক্লাসরুমে টাইম ওয়েস্ট না করে সরাসরি চলে যাব ম্যাম শাশ্বত ম্যামের কাছে। ম্যাম,
so I have the net for the 3D figure. So this is basically, you see, this is a cutout from a chart paper. So it has length and breadth. This is basically a two-dimensional figure. If I fold this figure up like this, yes, I will get this shape. Okay, so what did I do? I have taken a two-dimensional figure, and by folding it, I have converted it into a 3D shape. Okay, you can make nets in this way. See, I had a prism also. This prism, if you fold this paper up, you will get this shape. This figure will be converted to this figure. If you take the figure in the two-dimensional shape, it is this strip of paper. If you fold it up, you will finally get this figure. You can do an activity at home. You can make your own nets for your cuboids or any other polyhedron according to your choice. Mapping the space around through visual estimation, what do? Suppose if you have to organize a bookshelf, you have a book rack in your study and it is stacked with books. You want to place another book there. What do? Do you measure inch by inch and see whether that book fits into that rack? Normally we don't do that. Just by visual estimation you see whether you have enough space available or not, and you apply that book over there and see that it exactly fits into it. The next point is, I have already transformed the 2D figure into this 3D figure. I've made it into a cube. This cube, this is a 3D figure. Again, if I dismantle this cube, I will get back to my two-dimensional shape. Yes, and from this two-dimensional shape, I move on to the second part of the topic, which is symmetry. Now, what is symmetry? Symmetry means when you have object, figures or structures around you which has evenly balanced portions on both sides. That means one half of the portion will be exactly the same as the other half. These objects, figures or structures which have evenly balanced portions is called symmetrical, and the property by which they have evenly balanced portion, this property is known as symmetry. So now we move on to the common topics of symmetry. Look at this Taj Mahal. Yes, do you call it symmetrical? Do you have evenly balanced portions of on both sides? If we draw a line vertically through it and try to fold the Taj Mahal about this vertical line, we find that one part of the Taj Mahal will exactly fit into the other half. So this exists. Now if we draw a line horizontally, you will see that the two parts will not overlap, so this is not the line of symmetry. Now look at this figure. Does it have a line of symmetry? If I draw a vertical line, I will find that it is not overlapping the two parts. So this is an asymmetric figure. What about this? This is also not symmetrical. Now look for symmetry in nature. You can look for the fruits in your home which is available right now and see whether it has lines of symmetry or not. The vegetables which is available at home now, look for symmetry there and look for the lines of symmetry. Now a very quick activity you can do right now. Suppose I have taken a leaf. I have taken this leaf and I am trying to fold this leaf about the midvein. So see, the two parts of the leaf exactly overlap with each other. That means I can say that this leaf is symmetrical in shape. If we move on to the definition of the lines of symmetry, line of symmetry is basically the line which divides the object into two coincident parts. If I take this butterfly and I draw the line of symmetry here which I have shown you, this line of symmetry is also called the mirror line, and I try to fold this butterfly about this mirror line or the line of symmetry, I find that one part of the butterfly will exactly coincide with the next part. Symmetry of some common figures which we have in geometry. Suppose we take a line segment. I take a line segment of any dimension. Suppose I take 10.4 centimeter. There is no hard and fast rule, students, that you have to take 10.4 centimeter. You can take any dimension of your choice. It can be 4.4, 6 centimeter, 8 centimeter, and draw the perpendicular bisector. Students, you must be knowing how to draw the perpendicular bisector. When you draw the perpendicular bisector, you will find that P is the midpoint of this line, and if you try to fold this figure about the line CD, you will find that the measurement of XP will be exactly the same as the measurement of PY. That means P is the midpoint of the line XY. So you are taking the line XY and folding it about CD. So the two parts are exactly equal to each other. Now if we move on to an angle also has one line of symmetry. If you bisect the angle, students, you have already learned how to bisect an angle. So you see AX is the line which bisects the angle, and if we fold this angle about the line CX, we divide the original angle which we have marked it as angle CAX and try to fold this angle about the line CX, you will see that angle CAX will exactly overlap with angle XAB. So it has one line of symmetry. If you move on to a scalene triangle is one where all the three sides are different and all the three angles are different, so it has no line of symmetry. I move on to an isosceles triangle. This is an isosceles triangle where the two sides are equal, so automatically the two base angles are equal. So if I take this angle which we call the vertical angle and I bisect this vertical angle and I try to fold this figure about this line, you will find that the two parts will exactly overlap with one another. So isosceles triangle has one line of symmetry. You can try this for your home activity. In the same way, if we want to move on to an equilateral triangle, students, this is an equilateral triangle. It has 3 lines of symmetry. See, I have marked the angles. All the angles are 60° each. So I draw the angular bisector of these angles and I try to fold this figure about these lines. You will find that there will be exactly 3 lines of symmetry in this particular figure.
ম্যাম থ্যাংক ইউ সো মাচ। আমাদের কাছে আর সময় নেই আজকের জন্য। আপনাদের দুজনকে অসংখ্য ধন্যবাদ এতক্ষণ আমাদের সঙ্গে থাকার জন্য এবং এত সুন্দর করে বোঝানোর জন্য। তবে আজকের মতো আইসিএসসি ক্লাসরুম এখানেই শেষ করতে হচ্ছে। তবে তোমাদের যদি কোনো রকম কোশ্চেন থাকে বা কোনো কোয়ারি থাকে তবে অবশ্যই মেল করতে পারো। তার জন্য মেল আইডিটা একবার বলে দিই, info@asiscwbc.org। আরও একটা আছে support@asiscwbc.org। আজকের মতো আইসিএসসি ক্লাসরুম এখানেই শেষ করছি। টেক কেয়ার।
मैडम ये तो जादू की छड़ी है।
इसलिए अपने फैब्रिकेटर को बोलिए कि ग्रिल बनाए तो
सिर्फ SRMB रियल स्टील से।